So, Ichi, we have good news. The MMT just got to the conclusion that the blanket underneath the CDR window is safe for return. There is no issue. We had new analysis that showed that the debris transport would be no issue, and we came to the same conclusion with the Ames tunnel test. So basically, no EVA4.
Thanks, no EVA4. That's, I would say, good news.
Julie Wiley, have you on the horn. MPLM configuration for entry is complete.
Very nice. Great work on your part.
Thanks.
Well, good afternoon, everybody, and welcome to today's mission status briefing following a busy day on orbit and also a busy day with the mission management team. We shot some footage inside the flight control room this morning during the crew's downlink commemorative message, and we're going to replay that after the briefing today. We also shot some footage inside the mission management team meeting room, and we're going to replay that for you also right after the conclusion of this briefing. Joining us today is Bob Castle. He is the STS-114 mission operations representative. He'll cover all of the activities that have been ongoing on board Discovery and the International Space Station over the last 24 hours and look ahead toward tomorrow. And also joining us once again is Wayne Hale, who is the Mission Management Team Chair. He's also the Deputy Manager of the Space Shuttle Program. We'll hear from both and then open it up for questions. And with that, I'll turn it over to Bob.
Okay, thank you. Glad to be here again today. It's been a very, very good day in space again. The crew's gotten quite a bit done. The vehicles, both the station and the shuttle, continue to operate very, very well. We've had no real problems to talk about. We have stopped consideration of an EVA to repair or to make any changes to the thermal blanket on the left side of the shuttle, and Wayne will talk more about the rationale for that we went through in the MMT. But the flight control team have stopped any work on that as of now, and we have informed the crew. All of the transfers into the MPLM are complete. That was the main purpose of today, was make sure we get everything we're supposed to leave on station, and everything we're going to return back into the MPLM. All of that is complete. The MPLM was not birthed, it has been grappled by the station robot arm, and it'll stay that way overnight. We've also installed the controllers for the berthing mechanism, and those are being checked out. So far, everything is working well, and we're ready to unberth the MPLM tomorrow, put it back in the orbiter's payload bay. Looking ahead to that, that is the subject of tomorrow. We're going to, the MPLM unberthing starts around 2 o'clock in the morning local time after the crew has obviously gotten up. It should be back in the payload bay on the I think I showed the berthing starting around 6:30 a.m. So fairly early in the morning, Houston time tomorrow, the MPLM should be back safely in the shuttle's payload bay. Following that, we will hand the orbiter boom sensor system, the long inspection boom, which has been held by the shuttle's robot arm all this time. We'll hand it back to the station's robot arm, and the station will then berth the sensor system back in the shuttle's cargo bay on the starboard side, and we'll get everything cleaned up, pretty much ready for undocking, which will be occurring the next day. And undocking is around 2 o'clock in the morning on Saturday. So everything's going very, very well. We're looking forward to a good next few days, and then we'll be looking to bring the vehicle home. That's all I've got. Wayne?
Okay, well, let's see. I want to talk technical first, and then we'll do a little bit else. Can we start with the little video that we have, or at least the freeze frame from the video showing the window blanket that the MMT has been talking about the last couple of days? There you go. I think you've all seen this quite extensively, this small thermal blanket that is hoofed out underneath the commander's far left-hand window. We've been talking very carefully about that, and the point here is that we're taking every anomaly very seriously on this flight. We had early on decided that if that blanket, or not decided, but had thermal analysis showing that if that blanket came off during the entry phase, we're not concerned about heat effects on the structure, well within the capability of the structure underneath, no problems with the air loads underneath. That's strong enough to take all the air loads, and no concerns about the immediate area hitting the white tiles or the window up above. What did transpire after the aerodynamic folks got done with the gap filler analysis was a slight concern. Well, it was a concern. I don't know how you say it. It's not slight, but a concern that a piece of this blanket could fly off and hit the after part of the vehicle. After some analysis, we decided that we did not have enough engineering test basis to understand what might happen, how it might happen. So we elected to run a wind tunnel test. We expedited 3 test samples to the Ames Research Center, and they set up to run wind tunnel testing for us. And I've got some pictures of the result of that wind tunnel testing that completed this morning. So if we could go to the first. There's a picture of what we're calling test article number 1, a blanket with representative material around it that's damaged in a manner as closely as the folks could make it, the damage that we see on the blanket on the vehicle. And we ran that through a simulated ascent profile to get whatever damage the ascent buffeting would have done to the structure of that blanket, and then ran a simulated entry profile, actually ran it twice. I don't have pictures from the second run, but the following pictures are from the end of the first run, so if we can take a look at the next picture. Here's what the blanket looked like at the end of a complete ascent and entry simulation in the wind tunnel at Ames, and you can see that some small pieces have departed, but in bulk the blanket is still there. Next slide, please. And here's a real close-up. You can see the ceramic coating, a white ceramic coating that's put on the outside as an anti-fray device. Has started cracking off, and a few of the strands of the quilting have come undone, but by and large the blanket is intact. Next slide, please. A little bit different view down at the end of the blanket. Again, this after our first run. See, is that all, or do we have one more? That's all, okay. The point being that fabrics, soft goods, are very hard to analyze from an a priori engineering standpoint. You need to be anchored in test. We ran this particular test article through 2 simulated entries. Those were pictures from the first. We ran it a second time with very little additional damage resulting. We've got a second test article, very similar, same configuration, that we put in the wind tunnel at slightly higher than we expect conditions, and that run I think should have been completed by now. I was waiting for those results and I haven't quite heard, but again our indications are that nothing will come off, or at least if it does come off it will be very small, a few threads, a few little pieces of the blanket. Also, in correlation with this work, we did a large amount of structural analysis trying to determine that if a large piece, now remember, if the whole top of the blanket comes off, we're talking less than an ounce piece of fabric. But we are talking about coming off at supersonic speed. If that whole top of the blanket came off and impacted structure, we begin to get a handle on what it would mean to the structure. In some areas, as you might imagine, it was not a concern. In other areas where it could hit flat on, it was somewhat of a concern. The aerodynamicists looked very hard at the transport model, and we did a lot of work with aerodynamic debris transport for the analysis on the launch phase, but this is the first time that we really applied it to the entry phase, and they came back with a number that if you 100% guaranteed that a piece came off at exactly the worst time, full piece came off, then you had something like a 1.5% chance it was going to strike the structure. So not a complete clearance, not a complete clearance by any of them, but relatively low. And then when we did these wind tunnel tests and have more or less demonstrated that we're not concerned about the big pieces coming off, we feel that we are good to fly as is. We had a rather lengthy discussion at the mission management team, talking through all the possibilities and trying to understand the engineering data in great depth. and came to the conclusion with a poll of the UMT members that we were good to stand down on the EVA. We were good to fly as is for entry, and in fact we have stood down on the Launch on Need rescue vehicle as well. So those were the big decisions out of the MMT. I have to tell you that this was a huge effort. This little blanket turned into a huge effort. And I think it is remarkable that we have this capability to look at this blanket in such depth, this very small thing, and I would say the same about the gap fillers, that we have this capability now in flight to look at these small things, and then we have a team that is well prepared and capable of doing an analysis and doing a great deal of work in a very short amount of time to analyze what the threat is and what we need to do about the threat, if any. And that is something that we did not have before. Quite frankly, there were people that had dissenting opinions. We heard a number of dissenting opinions at the MMT. There were a number expressed in prior meetings that I'm very pleased to say the manager of the various organizations brought to the MMT for our consideration. To me, some of this was eerie, quite frankly. We had Rodney Rocha, if you remember. Rodney was prominently mentioned in the Columbia accident report, came forward and gave us what I consider to be an outstanding assessment of the unknowns, the variations, the risks that were inherent in all of this analysis for our consideration as a mission management team. John Cowell, who was also prominently mentioned in the Columbia accident investigation, came and gave us a very strong discussion about his evaluation of the thermal protection system and what this meant. If you'll remember some of the emails that went around during the that we found out about during the course of the Columbia accident investigation, I have exchanged email with Bob Doherty, formerly of the Langley Research Center, and he has reminded me, I think, of some very profound philosophical points of discussion that I've been thinking about very heavily. And so I've got to tell you the difference between where we were before and where we are now is profound. I am not here to tell you that we are 100% confident that there's no risk during entry. That would be untrue and foolish to even try to make that case. What I am here to tell you is we've assessed this risk to the very best of our engineering knowledge, and we believe that it is remote, small, whatever adjective you want to put with that, and the remedy that might be called for to try to make this better would be worse. We would violate the do no harm principle. So we believe that the chances of anything untoward happening with this piece of fabric is remote. But I'm not here to tell you this is not a pre-flight certification effort. This is an in-flight assessment effort. And there's a different time standard available, and there are different engineering standards that one must look at. And so, the best of our knowledge and ability, we have made risk trade and believe the vehicle is safe to fly for reentry. We've told the crew, they're aware of it, and this is a long, rambling discussion, I know. I apologize for that, but I'm very proud of the engineering team all around the country that has stood up and worked so very hard to provide an outstanding package of information for the managers that needed to make these tough decisions. So with that, I'll stop and let you guys ask questions.
Okay, that's Royce, your choice. We'll run the line and we'll start with Mike.
Mike Cavish with the Orlando Sentinel. A couple of questions. First for Wayne, elaborate on what you were talking about just a moment ago about the sort of Columbia connection here. You guys have been looking at some really tough issues over the past week as far as the gap fillers are concerned and as far as the blanket's concerned. And what sort of practical examples can you give us of places where things that have changed or differences in your procedures in the MMT's operation, how did that sort of manifest itself in these discussions, and how were things different as a result well. And secondly, just real quickly, I understand you probably can't give me details on this, but one of the CABE recommendations also was for you guys to work with NEMA to get on-orbit photography, and I simply wanted to ask, did you get the photography and was it useful?
You know, we put in place a great number of new technical tools. We have a whole suite of understanding of impact tolerance, the sorts of things that were discussed in the Columbia Accident Investigation Report about the crater. If you remember, a computer program that estimated impact damage. We have 3 or 4 generation more sophisticated, anchored in test data, well understood engineering models that help us understand what would happen if the orbiter structure, the thermal protection system, or in fact the underlying metal structure gets struck. We have these debris transport analyses, which are several generations more sophisticated, that tell us where things will travel, could travel in supersonic flow. That is just night and day difference. We have a much larger team invested in evaluating all of these things. We have independent reviewers that are part of every step of the way, so that alternate thoughts are brought into this. And finally, I guess the most profound thing is we put the orbiter under a microscope. I mean, we're out there with every little spot, stuff, ding, you name it. It's not ignored, it's not brushed off, it is evaluated by a large team of engineers who are very knowledgeable about the orbiter, and we're operating from a position base of knowledge rather than some sort of guesstimate. As to the last part of your question, I would say we have agreements with a number of national agencies, and those are being exercised during this flight.
John. For Wayne, John Kelly from Florida Today. Did you all have some pre-flight, and I know you've been unplugged from this for a little bit because you've been shepherding the mission through, but pre-flight, did you have some dissenting opinion about things related to the tank on the more frequent or more likelihood of hand-molded pieces of the foam being easier to liberate, and how did you all disposition that?
Well, going back to the last several months before the launch of Discovery, we had a large number of discussions at the technical level, the management level, about the fly-as-is foam, the foam that had been sprayed before the accident that we left on the vehicle. I think we've extensively talked about that in the past. There were a large variety of thoughts about different aspects of that subject. We had a large number of folks look into that. We had a number of dissenting opinions, which we tried to investigate very thoroughly. And again, I've got to tell you, I think we said it before, and I'll say it one more time, we missed something here. That has got to be rectified before we fly again.
Tracy.
Tracy Watson, USA Today, for Mr. Hale. When you polled the MMT about whether or not to do a 4th EVA, was there unanimity, and did John Cole and Rodney Rocha both in the end agree that flying home as is was all right?
When I say I polled the MMT, there's a list of about 20 formal members of the MMT that I polled for a go, no go, and I got unanimity in that poll, yes, very strong and emphatic unanimity. As to the question of those two individuals, from John Cole, I got a very clear and emphatic yes. He is responsible for the thermal subsystem, and he feels very strongly that leaving this blanket alone and flying home as it is during entry is the right thing to do. Now, Rodney, on the other hand, I didn't ask that kind of decision from him, but he did clearly want us to be aware of, as a management team, the risks that we have remaining out there and the unknowns and uncertainties in the engineering analysis that frankly would take weeks to months to resolve. So he said several times that he wasn't there to propose we didn't fly home as is, but he just wanted us in the decision-making role to understand the uncertainties that still remain off of this admittedly very rapid set of tests and analysis that have been run.
Gina?
Gina Sinceri, ABC News. Why didn't you ever want to go back to the folks from 20 years ago and say, why didn't you just put this into place? It would have saved us a lot of time, effort, and money if you'd done this.
Well, the thought has occurred. But you know, I'm not sure how fruitful that is. What I'd really rather do is to take the lessons that we've learned and pass them along to the next generation of spacecraft designers and say, learn from what we did, learn from what our designers of the space shuttle got right, which was a lot, and some of the things that they got not so right. And as you build the next generation of aerospace or spacecraft vehicles, take what is good, build on that, make sure and avoid the things that didn't turn out so well. And I think that's the history. If you look at aviation, one of the reasons that aviation has such a strong safety record these days, commercial travel aviation, is because that there have been hundreds of generations of airliners, and in the early days they suffered a lot of problems, a lot of crashes, and they learned that there are some good ways to build airplanes, and then there are some ways that you ought not build airplanes. And frankly, we are in the first generation of winged space vehicles, and it would be really good, as Chuck Campbell said the other day when he was up here on the podium with me, if we had 10 or 20 designs that we had flown and we had a lot more knowledge. So we will get smarter as time goes on.
Marcia?
Marcia Dunn, Associated Press for Wayne. Two questions. In the 1.5% chance that the whole piece could strike the shuttle, was there any conclusions as to what the worst damage might be if that 1.5% did happen? And then I have one follow-up.
Okay, well, I kind of hate to quote probabilities because they never come back quite right. Given that you have 100% certainty that a piece is released at the critical Mach number, then there's a 1.5% chance that piece will strike structure, vertical tail mostly. Then there is a whole other set of analysis which is somewhat variable depending on the angle and the speed that it winds up striking with as to whether or not damage could occur. They took a what they told me was a worst case example for the rudder if it's opened up and acting as a speed brake, which it is in the flight regime of interest. That if the 0.8 of an ounce piece of fabric blew a hole through the speed brake panel, and that crack propagated to the edge of the speed brake panel, you would have a hole that would be, let me see, what was it? Some number of inches by as long as 6 feet long, and the entry flight control folks did an analysis and determined that that would be completely well within the capabilities of the vehicle to control. So, okay, there were a lot of ifs in that chain. And again, I will refer you back to the discussion I had before. There are a lot of assumptions in that chain. And there's probably a lot of variation on that chain. So is that the absolute worst thing that could happen? Well, no, it's not. But it is a reasonable set of assumptions that leads you to kind of a reasonable, this is probably the worst thing that could happen sort of case.
And secondly now, can you say unequivocally that you have cleared Discovery to re-enter?
We have cleared Discovery to re-enter, and we have recommended that we not take any action, not recommended, we've decided not to take any action on the thermal blanket because we think that it represents negligible concern to us at this time.
And the television.
It seems like this has been a very long, drawn-out process to get to where we are now. Can you tell me the mood in the MMT when it was finally decided to formally clear the shuttle for reentry?
Well, let me see. It's hard for me to say, but I would say that to everyone, to the best of my knowledge, and I did quite a bit of wandering around and talking to folks after the MMT, felt like a good decision had occurred, that we're relieved that a decision had been made, and frankly glad that we could wrap this one up and move on to other things.
Tarek?
Thank you, Tarek Ralph with Space.com and Space News. Well, with the thermal protection system, put to bed for now, then, what are you going to be looking at over the next few days after undocking and coming up on reentry? What are those critical points that the crew just can't miss to make sure that everything is normal for the rest of this mission?
I'm going to let Bob handle that one.
Well, there are a lot of things the crew has to get done. The major activities are undocking, of course, and then get the cabin ready for entry, stowing things. There's still going to be stuff that's loose that they've got to get put away. We'll do the flight control system checkout, which occurs on, where does it occur? It occurs on Saturday night. To verify that all the flight control systems are operating correctly, we'll start one of the hydraulic power systems up, verify that all the aerodynamic surfaces of the shuttle will move correctly and move the right ways. All of that's going to get done, and those are fairly important things to get done. And then the actual deorbit itself. In terms of the thermal protection system, there's really nothing more that the crew's going to be doing.
Royce, let's start with Irene.
Thanks. Irene Klotz with Reuters. I have two questions. First, a quick one for Wayne. What is the highest Mach number that you did the wind tunnel test?
The aerodynamicists told us that the airflow, because you're pitched up to a high angle of attack during reentry, and then you start ramping down as you get toward the subsonic time period, so that there was no danger of recontact above about Mach 6 if it comes off, if anything were to come off this location before Mach 6. And then the kinetic energy from anything that might come off that would cause you any concern basically reduces to a low enough level you quit worrying about it by about the time you go subsonic at Mach 1. So we really concentrated our efforts in the supersonic range from Mach 6 to Mach 1.
And for Bob Castle, if you wouldn't mind trying this one. We all know that it's very difficult to lose people that you're close to, but I'm wondering if you had been able to do this sort of engineering and analysis on the fly, and you tried the best that you could to do something for Columbia and the crew and still lost the ship, would the recovery have been any different in the repair efforts, and do you think that NASA would have been able to move on faster and fly sooner?
That's an interesting question. I don't know that it would. I don't know that it would make anything any easier. I mean, it is very, very difficult to lose a crew and lose people that we know and our friends and colleagues. It certainly wouldn't have made that any easier to have tried to save them and failed. As to the recovery, I don't know that that would have. It probably would have sped that up somewhat because we would have known much more quickly what the damage was instead of spending months to figure out what it was. We'd have known what it was, but that would have sped things up. But I don't think anything else would have been different.
John?
John Schwartz, New York Times. This would probably be for Wayne Hale. Most of us are hearing two threads of discussion right now about MMT and the process of this mission. Part of it is the group of people that says, you got to do everything. Are you being cautious enough? Are you looking for every bit of damage? And the other half is going, oh, God, this bunch of Hamlets with their analysis paralysis. What's going on? This didn't like the old days. Do you feel whipsawed? And how do you deal with it? And, what does it mean to you, both in terms as an engineer and also emotionally? Thank you.
Well, let's see. I've thought a little bit about this. We have tried to be very open. Let me first of all say that. And we get a lot of criticism both from the NASA former employees, some of them, and from the public, I think, at some level. you know, there seem to be a lot of things going wrong here. You have a lot of things that you're worried about. Well, if we were not to tell you about this stuff, then I feel like we would get in trouble the other way, and you guys would say, well, you're too arrogant and you're withholding information and just covering it up. So we're trying to, I think, find the middle line here. We want to be very open. We want to tell you what we're doing. We want to tell you what our concerns are. At the same time, we are not in analysis paralysis by any stretch of the imagination. As you can see during this flight, we've had a number of issues. The flight has been conducted flawlessly. It is a thing of beauty that we docked with the station, we fixed up all the little parts that weren't working right on the station, transferred, I've forgotten how many tons of logistics to the station, air, water, food, clothes, computers, you name it. That has all gone flawlessly. We took, what, 15 minutes out on one EVA to take care of 2 gap fillers. And the fact that we've got a team on the ground that is actively searching out every potential hazard to ensure that the crew is safe to come back again, and the fact that we were able to do that inspection and analysis and carry it off successfully during this flight, I think tells me that those critics are probably misplaced.
We'll get Guy and then John, and then we'll go around, come back.
Thanks. My question was asked and answered.
Any other question? No? Well, let's go ahead and grab Kelly then.
Kelly, I'm the chief scientist for Wayne. Have you guys come any closer to pinpointing the source of this damage?
You know, that has been a topic of some discussion, and we did go back through the launch imagery from the cameras at the launch site, the high-definition TV and the video, the film, and all of the trackers, and we have not been able to pinpoint exactly when this happened or how it happened, any more than I've already discussed with you. You know, one of the things we'd like to do is when we get this back on the ground is look at this blanket in a lab, and perhaps there's some forensic chemical type evidence of what it was that struck it. We're pretty sure that the little repair that was done on that blanket prior to flight is intact. Well, no, we are sure. You can see that easily in the photography. So we don't think this was a repair that came undone. The current thinking is it was a result of impact damage, and we don't know. There is some other work going on with aerodynamics that potentially there was some shock wave interaction during the ascent, so I'm sure that will go on as well.
Okay, let's go to the Kennedy Space Center in Florida for a couple of questions, please.
Yeah, Dan Billow from WESH TV for Wayne Hale. I want to go back to the rationale for the gap filler repair, looking through the execute package, which seems to discuss worst case scenario, unlikely outcomes of failure of the RTV for the tiles, softening of the structure, burn through of the coating on RCC, and a complete burn through of panel 9 of the RCC, and my question is, am I understanding this correctly, and is that what you meant by bad things?
Yes. Next question.
This is Jay Barbary with NBC. Wayne, I understand a Tiger team was appointed a few days ago to solve the problem of the insulation falling off the tank. Could you tell us where that stands?
Jay, as you know, my focus here has been with the flight of Discovery and ensuring that the crew gets home safely, and as you probably have gathered, we've been quite occupied in that task. I do know that a Tiger team was set up. They have proceeded down to talk to the folks at Tank, and we expect to get a report from them in fairly short order. And frankly, I have not participated in that at all, and so I have very little intelligence to give you there.
And for what it's worth, from where I stand, you guys have been right on the top of this one. You've done a good job. Thank you.
Okay, we're headed to the West Coast to the Ames Research Center for a couple of questions out there.
Yes, this is Tomas Roman with Crown 4 TV in San Francisco. Given what you now know, this is to anyone on the panel, given what you now know, do you have any idea when the grounding of the shuttles will be lifted?
Okay, well, let me see. First of all, a shuttle's not an operational vehicle, so it's not grounded like operational vehicles are grounded. It's an experimental vehicle. Every time we fly the shuttle, and there is a requirement that we have a certification of flight readiness that says that every anomaly that occurred on the previous flight must be understood, rectified, or otherwise dealt with. So we are, at the moment the wheels stop on every flight, grounded until we do the engineering work to clear the problems that we had. And then when we have the flight readiness review, we have all the engineering and all the management sign their name on the line, literally, that they are certified to be ready for flight, that the problems have been dealt with, the risks have been mitigated, and all the fixes have been made. So this is no different than any other flight. We've had a problem here, and we will not fly until we fix this problem. And I might add, there is a list of about 23 problems. I think that's about the right number right now, that all of which have to be cleared, and any one of which is not cleared, we will not fly until they're taken care of. So that's the nature of having an experimental vehicle.
Wayne Friedman here with KGO-TV in San Francisco. Two questions unrelated. The first is that I think we sort of went through this a little bit, but maybe you could elaborate a bit more. With the resources and the information you now have, are you saying you could or could not have saved Columbia? And the second question is, if this is a flight with so much scrutiny, why are you landing in the dark?
We're landing in the dark because that's when orbital mechanics dictate you will land. That's the first reason. I would prefer to land in the daytime, but that is not always possible because we got off later in the window. The landing time moved to where it's before sunrise. We've landed a number of times. I will tell you from my previous life as an entry flight director, the weather's generally better in the wee hours of the morning, so if you can get past the fact that it's dark, you don't have to worry so much about thunderstorms and high winds and that sort of thing. As you know, we have a number of landing aids and these huge lights that we put on the runway to light everything up, and some of the shuttle commanders have told me they prefer night landings because it's such a wonderful visual target that you have when you land, and you're not distracted by the other things you might see out there. What was the other part of your question?
The other question was based on the information and the resources you have now. Based on the information and the resources you have now, could you have saved Columbia?
Well, you know, I think that was covered quite extensively in the Columbia Accident Investigation Report. I don't believe that we could have saved Columbia the vehicle. Was there a potential that if everything had have worked together perfectly and we had made decisions extremely early on that we might have saved the crew? I think that potential is out there and we have to recognize that fact.
Okay, we're back here for a final few minutes of questions, and we'll start with Mark.
Mark Carruth from the Houston Chronicle. I have two really actually clarifications for Wayne Hale. One is just on the wind tunnel testing, how crucial was that to getting you to the comfort level? I mean, could this have been done without that, or are you saying this is really the thing that you did this time that put you in the comfort zone? And then I have a follow-up, please.
I think that the wind tunnel testing was vital to this decision. We potentially could have arrived at the same decision based on the probabilistic study that I described from the aerodynamics, but the fact that we have these wind tunnel tests under our belt that show that we are not going to shed large pieces, remember large is like 1 ounce pieces of fabric off this blanket during entry, that lends a great deal of credence to the lack of concern that, well, that's not the right way to say it, to the decrease in concern that we have for anything bad happening to us.
Okay, thank you. My second clarification was just to make sure I sort of understood this, the last part of the rationale. I guess you're saying that if the piece came off, if it did come off, there was a 1.5% chance that it might strike something vital. And given that I now understand that with the nod of your head, what was the place you were most worried about being hit? I'm sorry, I think you said the rudder, but was there more than that? Because there were a couple of places mentioned before.
When the folks did the aerodynamic study, the orbital maneuvering system pod, which houses the thruster jet and their fuel, the probability of striking that part of the structure was very remote, down in a fraction of 1%. The primary thing was the vertical tail with the rotor speed brake panels being part of that vertical tail structure, and that's again given with the premise that a piece comes off at the worst time, then there's a 1.5% chance that it would strike structure, and we made no real distinction over vital or non-vital structure at that point. It's just a 1.5% chance that it would strike somewhere, and we would have to deal with that.
Max Hosby, over Canada. I'm not sure I understand right. There's one slight chance that something goes wrong. So why not do a fourth EVA? Is it a decision that you might regret eventually, Mr. Will?
You know, that's a very good question, and I would tell you that when you're in flight, many of your decisions are not absolute decisions. They are risk versus risk decisions. And doing an EVA is not to be undertaken lightly. Anytime you open the hatch and send people out in an EVA suit, there are a number of risks that you take. This particular EVA has got a great deal of operational complexity if we were to execute it this late in the mission. Frankly, that mitigates against it. But I think the real thing that mitigates against an EVA remedy is the fact that we don't exactly know what to do, because if your intention is to keep the blanket on better than it's clearly going to stay on, we have nothing to do that with. Removal of the blanket has got a high potential to cause other problems in the surrounding area. The batting that can come out of there is frankly a health hazard and a hazard to windows, star trackers, and other optical sensors, not to mention the EVA suit itself. So there are a number, it's not a free thing to go out there and say, well, we'll just do an EVA to fix this. We don't have a good technique on how to fix it, EVA, and even if we did, you do entail risk. So at a certain level, you say, which is riskier, going out and fooling around with this, or coming on in, given the knowledge we've got, and given the data that we have gotten out of the wind tunnel and off the aerodynamics study, it clearly is significantly less risky to return as is than to execute an EVA.
Quick one. What is the status of Atlantis now, please?
At Atlantis, well, we have released technically the team from launch on need status. They are stacked in the VAB, and we're within about 3 days of rolling to the pad if we needed to. And frankly, they are going to leave it in that configuration until post-landing, because we're developing the strategy for the next flight, and it's not clear which direction we want to go, back to the OPF or out to the pad, or stay in the VAB and do some repairs that's tied up with the next flight. So even though we told them to stand down on processing, and they would have been ready to roll out, I believe, Sunday night, if required. They are stacked and ready in the VAB, and should something change, we could certainly talk with them about that.
Bruce Nichols, Dallas Morning News. I hesitate a little to ask this question because it might seem rude. I don't mean it that way, but I need to push you a little bit on this point of deciding to land with a problem that you say you don't fully understand. How does that jibe with your statement yesterday that we're going to do everything we need to do to make sure the crew is safe?
Okay. Well, you know, at this point, you really have three choices ahead of you. You could try to go EVA and do something to this blanket, and I think I've discussed that at some length. You have to know what you want to do, and frankly, we don't have a remedy. The other alternative is to execute a launch on need, you know, cast Discovery off to a fiery death in the Pacific, leave the crew on the station for the 30 or so days that it would take us to get Atlantis up there, and then you go through all the risk of a shuttle launch, including all those things that we've talked about on this flight, to try to rescue the crew. Now, you weigh all those options against what is my risk of flying home as is. This is a relatively low risk based on the work that we've done. I will not tell you that it's zero risk. That is clearly not the case. I would tell you that even if this blanket were in pristine shape, there's not zero risk. But those are about the only three choices that you have at this point in the flight. And the lowest risk, the best choice, and the unanimous decision of the engineers and the management team is that we should re-enter as is.
Last two questions. We'll get Irene, or Mike, and then Irene.
Mike Catters with the Orlando Sentinel. For Wayne again, I wanted to follow up with a couple of questions about Atlantis' status. You mentioned just a moment ago the possibility that Atlantis might roll out to the pad, and I was just curious what sort of eventuality that might be for. And talk a little, if you would, about the sort of timetable that you're looking at for making decisions on things like destacking and move ahead plan. When are you guys going to start sort of figuring out where you're at as far as you know, potential launch dates and things of that sort? And also, what's the status of the tanks as well, as far as, you know, sending some back from the chute or getting new ones? I know it's early in the game, but what's your general take on all that?
All good questions. I have no answers. I'm really working on Discovery and get the Discovery astronauts back safely. And people are offline working on those things, and perhaps we ought to have them come talk to you about it. But I'm not in the middle of those discussions. And even though those are all obvious questions to ask, I don't have an inside track into what we're going to do. I will tell you that probably the day after we land, after I get a good night's sleep, and maybe take a day off, I'll be right back in the office, and I'll be asking those very same questions, and at some point in the not very distant future, we'll be back together and we'll discuss detailed answers to those questions.
And Irene?
Irene Foss with Reuters for Wayne. I know you can't put a tank in a wind tunnel, but with all this operational engineering and analysis you've been doing and the engineers have been doing, have you had any kind of epiphanies or any sort of insights that you will be able to share with the team looking at the ET issue?
I think you stumped me, Irene. I'm of epiphanies. At this point, no, I'm kind of epiphanied out. So.
Okay, that's all the time we have. Just a reminder that
immediately after this briefing, we will take you inside the flight control room. Thank you. You guys, I know these programming notes, you guys just wait for this at the end of the briefing, so we're going to take you inside the flight control room for this morning's commemorative message that came down from the crew, also the footage inside the mission management team room that I talked about. Crew wake up tonight, 9:09 p.m. Central Time. The station crew will wake up at 9:39. The mission status briefing tomorrow morning is scheduled for 07:30. And Wayne will conduct his mission management team tomorrow, but we probably will forego a meeting because he's going to meet early Saturday morning. So we'll tie those two briefings together on Saturday sometime after the conclusion of Wayne's meeting. So with that, stay tuned for that footage. Take care.
Nach Auffassung der Experten besteht keine Gefahr beim Wiedereintritt in die Atmosphäre. Zuvor hatte die Behörde geprüft, ob ein weiterer Schaden an der Fähre vor dem Rückflug behoben werden muss.
Vor genau einer Stunde bekam die Discovery vom Kontrollraum die Entscheidung. Wir haben gute Nachrichten. Die Isolierdecke am Cockpitfenster ist kein Problem für euren Rückflug. Alle Tests, inklusive einem Windkanaltest, kommen zu demselben Schluss. Mit anderen Worten, es steht euch kein 4. Weltraumspaziergang bevor. Die Nachricht wurde im All mit Erleichterung aufgenommen. Die NASA hatte nämlich in der Nähe dieses Cockpitfensters Schäden an einer Isolierdecke festgestellt. Für eine Reparatur wäre ein zusätzlicher Weltraumausflug nötig gewesen. Nach der erfolgreichen Reparatur an den Hitzekacheln gestern erwartet die NASA an der Unterseite des Shuttle keine Probleme beim Eintritt in die Atmosphäre. Aber man hatte befürchtet, dass herausgerissene Stücke der Isolierdecke am Fenster weiter hinten in den Shuttle einschlagen könnten. Die Crew hatte sich schon am frühen Morgen zuversichtlich geäußert. Es gibt so viel Positives an diesem Flug. Es ist ein Erfolgskapitel für die NASA. Dies ist schließlich ein Testflug, da entdeckt man einige Probleme, aber wir haben alle gemeistert. Wir sehen das alles viel positiver, als es in der Presse dargestellt wird. Nun wird die Landung der Discovery für Montagmorgen erwartet.
Ungeachtet der Probleme an der Isolierung am Fenster des Space Shuttles soll es keinen 4. Ausstieg ins All geben. Das hat das Flugkontrollzentrum in Houston der Crew mitgeteilt. Es bestehe durch den Defekt keine Gefahr beim Wiedereintritt in die Atmosphäre, so die Begründung. Die Raumfähre sei sicher für die Rückkehr, so ein NASA-Manager. Damit steht einer Rückkehr am kommenden Montag nichts im Wege. Die Discovery soll um 9:37 Uhr unserer Zeit in Cape Canaveral landen. Bei mir im Studio ist jetzt Friedhelm Klaassen, Luftfahrtexperte vom Deutschen Zentrum für Luft- und Raumfahrt. Schönen guten Abend.
Guten Abend, Frau Georgi.
Herr Klaassen, wenn jetzt diese Reparatur doch nicht durchgeführt werden soll, gestern gab es aber eine Reparatur an einem Füllmaterial. Warum kann das Füllmaterial gefährlich sein und diese Isolierung, die jetzt beschädigt ist, nicht?
Man muss grundsätzlich zwischen den beiden Schäden unterscheiden. Der erste reparierte Schaden betraf die Unterseite, die für den heißen Wiedereintritt, wo also Temperaturen bis zu 1600 Grad aufstehen, erforderlich war. Dieser zweite Schaden, der jetzt nicht repariert werden muss, ist auf der Oberseite des Shuttles, oben seitlich unter dem Cockpitfenster und ist nicht für den heißen Wiedereintritt relevant, sondern nur für die Flugphase anschließend. Die Sorge war, dass sich dort auch loses Material ablösen konnte. Es ist eine fluffige Isolationsschicht, die da aufgebracht ist, vernäht, ähnlich wie eine Steppdecke. Diese Vernähung ist aufgeplatzt und loses Material könnte jetzt austreten. Es bestünde rein theoretisch die Gefahr, dass das gegen das Leitwerk stößt oder andere Teile des Shuttles, wenn er mit mehrfacher Schallgeschwindigkeit durch die Atmosphäre fliegt. Aber die Masse des Materials ist so gering und es ist so lose, dass die NASA-Techniker das sicherlich richtig entschieden haben, hier keine Reparatur zu machen.
Können Sie uns vielleicht noch etwas genauer beschreiben, wie groß diese Schadstelle ist?
Ja, der Bereich selber ist ca. einen halben Meter lang und ca. 10 Zentimeter breit, wo das Material richtig aufgequollen ist. Man sieht es also praktisch wie einen Schlauch fast hängen, sich vom anderen Material abheben. Vorderen Ende ist auch ein kleines Loch drin, kann man so sehen. Und da wird natürlich der Wind angreifen beim Wiedereintritt und das kann sich weiter aufreißen. Es könnte Oberflächenmaterial, ein Glasfasergewebe, sich loslösen, aber kleine Partikel, die dann in der Größenordnung einige Quadratzentimeter vielleicht durch die Luft fliegen, das kann aber keine ernsthaften Schäden am Shuttle verursachen. Dafür ist er viel zu robust gebaut.
Wie kann denn dieser Schaden nun genau entstanden sein? Ist die Discovery so schon losgeflogen? Wohl nicht, oder?
Das dürfte beim Startvorgang passiert sein. Es ist ja sehr viel berichtet worden über das große Schaumstoffstück, was sich abgelöst hat und was zum Glück zwischen Shuttle und externem Tank einfach nach unten durchgeflogen ist. Es gibt auch kleine Schaumstoffstücke, die sich ablösen. Die sind vielleicht fingernagelgroß oder vielleicht auch Tischtennisball groß. Und solch ein ganz kleines Stückchen, wenn es dort mit sehr hoher Geschwindigkeit einschlägt, kann solch ein Aufblähen, Aufplatzen praktisch verursachen. Und man sieht auch etwas weiter dahinter noch eine kleine Beschädigung bei einer weiteren Isolationsfläche unterhalb des Fensters, die auch völlig unkritisch ist. Aber das deutet darauf hin, dass dort ein kleiner Einschlag stattgefunden hat mit einer relativ großen Wirkung. Das liegt einfach an den sehr großen Geschwindigkeiten, mit denen diese Teilchen dann auf weiche Teile treffen und auch zu Aufplatzungen führen.
Vielen Dank, dass Sie uns das so schön erklärt haben. Friedhelm Klaasen.
Bitte.
Danke für das Gespräch.
Good morning, Discovery. The wake-up music this morning had a little bit of a Navy flair to it. Hope that Wendy appreciated that. We also hope that the music sort of puts you in a packing frame of mind for today.
Well, we obviously don't have any talent to do the wake-up songs up here. That's his floor. I tried to pawn it off on Vegas, but he wouldn't take it.
Well, sometimes you just have to take it yourself.
We're looking forward to a great packing day, and looking forward to putting the MPLM back into the payload bay.
And we're looking forward to that also. It's going to be a great day.
This view of the Raffaello cargo module now sealed up, the hatch closed, its systems deactivated, waiting to be demated from the Unity module of the International Space Station in about 3 hours, following the depressurization of the passageway between Raffaello and the International Space Station that served as the pathway for the transfer of cargo over the past week.
Okay, we copy all, Eileen, and with that, we're handing over from Orbit 1 to Orbit 2. And just to let you know, this is my last shift. You'll be getting CJ Sturk out tomorrow. I enjoyed working with you all, and I look forward to seeing you on the ground.
We copy that, Steve. We really enjoyed working with you, too. Thanks for all your support as a Capcom and CSA. It's been great, and have a good time off. We'll see you after you get back.
Thanks for those words, and I'll turn you over to Julie.
And good morning, Julie. We're looking forward to Orbit 2.
Good morning, Eileen.
Robotics officer in Mission Control reports the arm is in motion. These pictures coming to us from the intensified television camera on the end of the orbiter boom sensor system, which is on the end of the Space Shuttle's robotic arm. Later today, the Shuttle's arm will hand over the OBSS to the station arm so that it can be rebirthed in the starboard sill of Discovery's payload bay for the return home.
Houston, Alpha, space to ground 2 for CBM. We completed step 1 through 12.
Soichi, we copy step 12 complete. Excellent job, and you are done with your part of the procedure. Thanks very much. Nice work. Procedure.
Thanks, we'll be signing off, but I'd like to appreciate all the hard work on the OSO team on ground, and our special thanks goes to Christine Bartels, and good luck with your new assignment in Germany.
And from OSO Minor, I'd like to reflect the same thing. Our OSO team did a great job training us, and operator saying to Christy, good luck.
And gentlemen, Christy is listening, and she really appreciates those words. Thanks very much for saying that, and she also passes along her congratulations. It was a job well done.
A view of the Italian-built Raffaello multi-purpose logistics module, a pressurized cargo carrier for equipment to and from the International Space Station as the space station complex orbits 222 miles overhead of the midsection of the United States. Here's a look at Raffaello's destination, the payload bay of Discovery.
Station Houston, Space to Ground 2, Vegas. We need Verns on the arm. It looks like we're having some attitude control issues. In Vegas, we just went free drift. We lost attitude control. If you can go, Vern.
After that, we're trying to stop it.
Nice view of the Raffaello multipurpose logistics module grappled by the space station's Canadarm2 as the station complex orbits 220 miles over eastern Canada. Canada, the International Space Station partner that's providing the robotics that are being given quite a workout on this mission. This is Mission Control Houston, continuing to receive live downlink television from the cameras on the International Space Station as the crew controls them to provide good visibility of the Raffaello module being guided through the space station's Canada 2 robotic arm. This orbital track will take the International Space Station complex about 220 statute miles over the Mediterranean just off the western coast of Italy, where Raffaello was built. Shuttle's attitude control systems being put into free drift so that the space station systems can be reassume attitude control of the stack. And the robotic arm operator has given the crew on board the shuttle and station go to begin movement again of Raffaello using the course or fast rates for the robotic arm. And this is a view of the Raffaello module on the end of the space station's robotic arm. This view coming to us from the elbow camera on the space shuttle's robotic arm. It's a sequential still video image brought to us through the S-band communication systems when we're at a range of the higher speed communication links that normally bring us live television. Raffaello flying overhead of its home country of Italy at an altitude of 222 miles now on a southeasterly track that'll take it over the Mediterranean and then the eastern portion of the African continent. This look at Italy's Amalfi Coast as Raffaello orbits overhead.
Good day and welcome back to the Johnson Space Center for today's mission status briefing on the progress of Discovery's flight at the International Space Station. With us today to discuss the morning's activities are the lead shuttle flight director, Paul Hill. Paul?
Today was a busy day inside Discovery and Station. Everybody was involved in one form of transfer or another. Most of this was equipment being shuffled between the middeck and the inside of Space Station. Jim and Wendy are busy right now using the station arm to return the logistics module to the payload bay, after which the two of them, Andy and Charlie Camardo, will use both arms to put the OBSS back down in the latches and cradle it for the first time since flight day 3. We'll finish the day up with everything ready to close hatches tomorrow and undock at 2:24 in the morning Houston time. And I have a few numbers for you. For this mission, our final transfer numbers are 23 pounds of nitrogen, 1,700 pounds of water in 18 bags. We transferred 1,400 pounds up from the middeck and 3,800 pounds up inside the logistics module, and we're bringing back 1,300 pounds and 5,000 pounds in the middeck and the logistics module, respectively. And that's everything for me this morning.
Okay. Quick start, ready for questions. We can start in the front row. Gina.
So you had a little problem with the gyros on the space station spinning out today. If you want to talk to me about that, just a little bit of education.
Yeah, it wasn't really a problem. We saturated the control moment gyros, which just means that we had enough momentum that we lined them up and they were no longer capable of reacting or holding the attitude for the combined stack. There was some risk of that during the logistics module robotics. We knew that. We thought that we would be able to get away with operating the station arm at a little bit higher speed so that we could shorten the amount of time it would take to install a logistics module back in the bay. And we found out that while we thought we were in fact close, we were just over the edge, and we saturated and the station went free drift. Shuttle's holding attitude now on verniers. When they finish with the logistics module and get it back down on the latches, we'll go back to space station attitude control, and the control moment gyros are fine.
Pam Easton, the Associated Press. I believe the other day when you were talking about the shuttle separating from the station, you described the maneuver it's going to do as 40. Can you tell us a little bit about that and what exactly it's going to do as it separates?
When we undock, we are going to fly around the space station. So Eileen and Vegas will back the shuttle out to about 400 feet in front of the space station, and then they'll fly a full loop all the way around the station with the windows facing the station, snapping pictures all the way around. Then we'll fly up above space station one more time where we'll do our final separation burn and fly away, and then we'll end up down below and in front of space station after some time. The only reason we're doing it is to take pictures of the space station. There's no technical reason other than the fact that we can see all the way around. And since we're there, we have the time in the crew schedule. We easily have the propellant on board, so we're going to take the time and snap some pictures from some angles we haven't seen since the last orbiter was there.
John Johnson, Los Angeles Times. Not to bring up an issue that has already been put to bed, and I think many of us hope remains there. There was another wind tunnel test that had not been completed, or we had not been told about yesterday, in which they were going to have higher forces. Do you have the results of that? Is it still good for the blanket in terms of that?
Yes, the second wind tunnel test confirmed the same results we saw on the first wind tunnel test. No concerns, no issues with that blanket coming off under the expected air loads. We're good to go to land as is.
All the testing is done, it's clean, it's ready to come.
That's correct. All testing, all analysis is finished for the window for landing, and we're ready to go.
Mark? Then we'll do Bill.
Mark Perot from the Houston Chronicle. I had a couple questions. Now that the thermal protection system is cleared, are there any other systems aboard Discovery at this point that you're working to get up to full spec for the reentry, or does everything else look pretty clean at this point? Then I had a follow-up.
Everything else on the vehicle looks clean. We're in real good shape. Leroy's already started looking at the consumables we have on board to sharpen his pencil on exactly how many opportunities he wants to use on Monday, Tuesday, and Wednesday. But that's pretty much the work that we're doing right now for entry. No systems issues whatsoever.
And do you have, I know this was a 12 plus 2 and then you went to 13, but do you still have 2 weather wave off days at this point, or are you really kind of down to 1 in addition to the 13 days of the flight?
No, we still have 2 other wave-off days. When we were talking about having a 4th EVA, it's possible we would have used one of those weather days to make another day while we're at station, or to add another day before deorbit. But with that behind us now, we undock tomorrow. Our normal landing on Monday still gives us Tuesday and Wednesday to get on the ground if we have problems.
Bill?
Bill Harwood, CBS. Paul, I was just glancing through the execute package, and I just really was glancing through it, and I was looking at the wing leading edge sensor data that you guys sent up. The 2 probable impacts that is listed in there, what do y'all think those are, just out of idle curiosity?
Yeah, and I haven't heard any speculation at all, Bill. I haven't seen any detailed reports to correlate those particular impacts back to foam. And it doesn't mean it didn't happen, but the only MMT I've been in for the entire mission was yesterday. So if they reported it at an MMT, I didn't hear it. I heard all the details on the specific damage locations we were worried about and we inspected, but I haven't heard any positive correlation back to those impacts.
Tracy.
Tracy Watson, USA Today. A question and a follow-up. Now that you've cleared the TPS for reentry, what are your remaining concerns about getting the orbiter back on the ground? I assume that even though you have cleared TPS for reentry, you're not. This is still not a perfectly, risk-free activity.
No, deorbit's not perfectly risk-free, but the vehicle is in pristine condition. So we're not worried about any systems not performing for deorbit. Our big risk now, aside from the inherent risk of deorbiting through a fireball, would be weather, which is absolutely outside of our control. So we're watching weather at KSC and at Northrop and at Edwards, and Leroy will have his work cut out for him over the next few days.
Just to follow up, I don't know if, like the administrator, you would tell us to think of you as Spock, but I'm wondering what you are going to be thinking about during reentry and landing, whether this will be an emotional time for you or not, especially thinking back to the last landing.
Oh, I assume that before I go in the building, I'll have a thought or 2 about the 107 crew. We talked about this before launch, and there haven't been many days in the last 2.5 years that I came into work and wasn't thinking about them at some point or another on the way into work, maybe even throughout the day, depending on what we were doing. During the mission, most of our effort on console takes so much of our focus that we didn't think about them a lot consciously while we're executing, because we did have our hands full. Obviously, during the crew commemoration yesterday, they were on our minds a lot. During deorbit, I'm sure I'll have a thought or 2 about Rick Husband and his crew, since I'm pretty much going to be a spectator with everybody else while Leroy and the entry flight control team look over the crew's shoulders during entry. I would expect that Leroy and the flight control team, though, will be completely focused and just taking care of business. At wheel stop, I'm sure all of us are going to think a lot about the 107 crew as well as the 114 crew that we're going to be very happy to see on the ground again.
Bruce Nichols, Dallas Morning News. Apologize in advance for raising this question again, but I need to ask. This situation certainly looks different from what we had before Columbia re-entered, but there are at least some small similarities. It's a problem we don't 100% understand, don't know exactly what caused it. I think I heard Wayne say yesterday that we used an aerodynamic analysis for Ascent to study a re-entry problem. We had Rodney Roca raising cautions about what we don't know at this point. Any of that bother you at all?
Well, let's see. We don't necessarily know all the causes. In particular, say the blanket outside Eileen's window. The speculation is that was some kind of impact damage, but we don't know for sure what caused that. And so there is that similarity. The one difference for 114 and future flights from STS-107 is we carry tools up into orbit with us that will absolutely tell us the condition of the vehicle. Some of the analysis that we've had to do for this window blanket in particular isn't perfect analysis. It's not the analysis that would be good enough for us to certify landing repeated flights with this condition on this window. And that is something that Rodney Rocha brought up in the MMT yesterday in great detail. That is different than saying that the uncertainties are so large we don't have confidence in the tests or the analysis that have been done for that window. The folks that have worked on that are experts both in the aerodynamics and in the thermal protection system on the orbiter and the structure on the orbiter, and those folks are confident that we can land as is. And there was no dissenting view, there was no argument about that in MMT yesterday. By the time we had all of the data together after several days of working on it, it was very clear in the MMT we have enough data before us to be confident in that case. And then, as I said, overall, the glaring difference now from STS-107 is we do have these tools that will tell us what's going on the outside of the vehicle and on the bottom of the vehicle in places that we didn't have the capability of seeing before. And we have analytical tools available to us now to assess damage if we detect it that weren't available to us before the accident.
Follow, please. Actually, it's two small ones. The analysis actually was for ascent, but not for reentry, the aerodynamics he was talking about. And then second, he also said that the engineering criteria for deciding when you're in orbit or in flight is different from deciding before you launch. And I wondered if you could just talk a little bit about that.
And that's correct. There are risks that once we're in orbit, that we will accept, in particular for deorbit, where you're not fighting to get an orbiter back to the ground or you're trying to get a crew back to the ground. And you already have the vehicle in space, you've already accepted the risk of powered flight and everything it takes to get the crew up there. Now you're trying to make the best of the situation you have and evaluate the data and bring them back down to the ground. In that condition, or in that case, there may be some risks that you would be willing to take that if you had known about pre-launch, you wouldn't be willing to take. You would go out and fix before you launch. That doesn't necessarily mean it's a bad risk to take once we're in orbit, but it does fall in the category of if we had known about this beforehand, we'd sure like to fix that, so that's one less accepted risk we'll fly with.
And the analysis, the thing that I asked about, do you know if that aerodynamic analysis, I'm not talking about wind tunnel, I'm talking about aerodynamic, was for basically for ascent stuff and not for entry?
I don't know. I was not there when they talked to detailed aerodynamics the day before yesterday.
Irene.
Irene Klotz with Reuters. I know you're still in the thick of things, but from the perspective of someone who's orchestrating all these flight operations, can you talk a little bit about how this has been different for you from flights you've conducted before Columbia, and just some of the benefits that you see from all this extra attention and people in focus, and maybe some areas that still need to be addressed for smoother operations?
Well, the primary difference between this flight and other flights that I've worked as a flight director is that for this flight, we had a lot of things that we had to deal with for the last 2.5 years that we didn't necessarily know how to solve right away. I mean, we were working to figure out what caused the problem after STS-107, and not long into the investigation, we started working on the options necessary to get us back into flight while we still hadn't yet understood all of the problems that we needed to solve. That's kind of a new animal for us. Usually we go into a flight when we start planning it. We know exactly what we're going to do, and all we have to do is plan it. And we spent the better part of the first 1.5 years or so after the accident working on still solving some of the problems, like trying to identify what critical damage size is on the leading edge, or perfecting inspection and repair hardware, inspection and repair techniques. And there was a lot of debate internal to our community on almost every facet of the new hardware and the new operations that we've put together. Which is understandable given the reason we were working on these things in the first place. That level of emotion, the level of scrutiny we've had internally and externally, that's a lot different than our normal experience. That certainly adds to the pressure. The press that we had for the entire 2.5 years since the accident, focusing on NASA culture and our ability to do this safely, that of course adds some amount of pressure as we're doing this job. Since FOR, the Flight Operations Review in October, internal to our community in the flight control world and for the astronauts that were flying on board and the folks that work most closely with us to actually define and execute the mission, as we finished up that FOR and we got closer and closer to flight, we started performing practice simulations with the crew in the simulator and the flight control team and mission control. Then we had to start tuning a lot of those things out and focus just on what did we have before us. By that time, we had the hardware, we knew what our new flight techniques were, we had procedures, and it was just a matter of getting sharper and sharper and flying. So as we got closer to flight, we were able to tune those things out and just focus on being ready for the day we actually launched and put Eileen and her crew up into space.
We'll start off with Kelly here on the front.
I hope I answered all your question, Irene.
Kelly Young with New Scientist. Do you have an early weather forecast for Monday?
We have been tracking weather for the last couple of days. I almost hate to talk about weather on Monday because especially in Florida, it's so darn dynamic. Today the forecast doesn't look so good in Florida and doesn't look so good at Northrop, but it looks pretty good at Edwards. But I think we're not really going to have a really good look at weather for landing until Sunday. My guess is Leroy's probably looking at that twice a day already.
Let's see. Tarek, you had a question.
Thank you, Red. Tarek Malik with Space.com and Space News. Paul, a couple of days ago after the gap filler procedure, you had mentioned that once that was complete and the blanket was put to rest, that it would pretty much feel like it might be all downhill from there. And I'm curious, are you at that point now where a lot of the first ever demonstrations of the boom of the tile repair are behind you, and undocking, fly around, these are things that you've been through before. Is it all downhill from now, or are you going to be on pins and needles until the orbiter's on the ground?
I guess it's all downhill from a certain perspective. We definitely have all the new operations behind us, all the contingency cases that we were worried about, like the gap filler, like the blanket outside Eileen's window. Those are behind us now. We fixed the gap filler. We convinced ourselves that the blanket is good to land as is. So with those, from a certain perspective, it does feel like it's all downhill. Now the logistics module is still going into the bay now and moving around a big heavy object like that with the space station arm and latching it down to the payload bay. We've done it before. It looks easy. That's something that we all feel better about when we're finished rather than when we're starting. But it is something we've done many times and have a lot of experience with. Undocking, the fly around, the SEP tomorrow, that's also something we have done many times. So there's less anxiety about it. I will probably sleep just a little bit less today. I guess it's not tonight, but later today, since we have the undocking and the fly around tomorrow, even though we've done it many times, and it is relatively easier than rendezvous and docking. We still do fire up a lot of additional systems on Shuttle. It does still require Eileen to fly in proximity operations to station, which gets our attention, and there's various ugly contingency cases that we'll be nervous about. But compared to first-time operation of the OBSS or waving the arm around with this big boom and the lasers around the leading edges, the rendezvous pitch maneuver, all of that photography, all the new things we put together. Compared to those things, this will feel more comfortable. But it's still real flying in space with real risks, and we'll be more relieved at wheel stop when we see the crew step off the vehicle.
Andy.
Andy Patag, Fuji Television. This is a related question, but after having done this 100% inspection, and now that you know more about the TPS system and the soundness of the shuttle in general, what's it like to bring this one back as opposed to earlier flights when you really didn't know exactly what you were dealing with?
Well, as I said, it is much better going into deorbit when you know about so much more about a risk like TPS impact damage, and the fact that we can't make that zero. Having the tools to absolutely know the condition of the outside of the vehicle definitely gives you a lot more confidence. If we had gone into this entry without having the additional tools and knowing we still had the risk, we would be more nervous than we already were about entries. The fact that we have these tools definitely makes us feel better about it.
Okay, we'll take Bill, then we'll go down to the Kennedy Space Center, and then we'll come back here for follow-ups. Bill?
Yeah, Paul, I guess tonight's your last shift on this mission. You spent years now working on this flight, and it's finally drawing to a close. And I guess you're leaving the flight director, I guess, chair. This is your last shift. So Would you look back on this mission, how do you sum this up? You had the foam, you've had these things that got all this intense media coverage. It's really been kind of a roller coaster in the outside world anyway, and I think maybe a little bit on the inside. Can you just give me a sense of how do you sum up this flight, given all the time and effort that's gone into it?
Let's see. I guess I would probably sum it up a couple of three ways. One, the flight control team, the flight control community, once again inspires me when I watch these people do what they do and make it look like something as simple as driving your car down the street. And what they're really doing is managing the systems on a spaceship like the Space Shuttle or the International Space Station, and they come in and do it day in and day out, and like I said, they make it look easy, and they are just so good at it. It just reminds me how good the folks still are in this agency and in this business. From a flight perspective, one of the things that stands out the most in my mind and will stay with me the longest, I think, will be that so many of these new things that we came up with, we didn't even know how to approach the questions in February of 2003. We knew we had problems we needed to go assess, say for inspection and repair. We didn't know how to begin to attack the problem. We weren't even really sure what entry critical damage was. And so much of the problem looked impossible. Many parts of the problem had been declared impossible 20 years before. So going into an effort like that, where we were working on things that we had officially declared not possible, was a relatively daunting task. As we got into it, even some of the things that in the operations community we thought were possible, other parts of our community, in some parts of the operations community, still thought were impossible. As recently as a year and a half ago, parts of our community still believe many of the things that we just did in flight were impossible. It is heartwarming for me to look back on this flight and see how many of these things that were considered impossible, even internal to our own community not that long ago, came off without a hitch. All of the inspections, both the ones we planned to do pre-flight, the ones we hurried up and planned in flight, whether it was for RCC, for tile, for the window blanket, all of those things we did like we'd been doing them for years and years, and they worked perfectly. The new sensors worked perfectly. The run of a pitch maneuver went off without a hitch. The pictures were eye-watering. Those are the things that are going to stick with me, is that even internally it was a slog. Even internally we were debating whether or not any of this stuff was feasible. Well, we just demonstrated not only is it feasible, we can do it and make it look like we're standing on our heads. That's going to stick with me for a long time.
Okay, let's go to the Kennedy Space Center for questions, and we'll come back here.
Paul, this is Jay Barbary with NBC News. Assuming that the most critical part of the mission remaining is entry, could you tell us what you specifically think will be the most critical part of entry itself?
Well, you know, I guess there's various parts. Leroy would give you a lot more intelligent answer than I would give you, since he's had to deal with it probably 5 times a day, 3 or 4 times a week in the last 2 years. But the entry heating is the obvious one, and getting down through a cloud of 6,000 degree plasma with the wing leading edge and the bottom of the vehicle still intact. But after you get through entry heating, you still have a high Mach number. You have a very, very fast supersonic aircraft barreling through the atmosphere, coming down at a pretty high rate that eventually needs to become aerodynamic and start turning towards the runway and hit the runway with the wheels in the right place and the right amount of energy, and you only get one shot at it since we're just a great big glider. All of those things are pretty darn critical.
Thank you.
Okay, that's it from the Kennedy Space Center. We're back here in Houston. Let's see. I think Mark has a question here.
Mark Carruth from Houston Chronicle. I have a couple of questions. On the fly-around maneuver, who flies that, and is there anything specific on the station that you guys are after this time in terms of photo documentation, or do you just want a really good broad survey that's updated?
Specifically with the hand on the stick for the SEP, I mean the undocking and the fly around, that'll be Jim Kelly, which is sort of a tradition that the astronaut office set up some time ago. Eileen and Jim will both be on the flight deck and both be controlling the systems necessary to fly around and away from space station, but Jim will have his hand on the stick. The targets for the fly around survey, it would not surprise me if the Photo TV folks hadn't put up specific targets to the crew. I don't know what they are offhand, but we do want a very broad survey all the way around the vehicle.
Mark, you had a follow-up? Mark?
You gave a really nice answer to Bill about a question I have that's similar, but it seems like you've kind of broken through on this flight. You know, it's tough to do after you've had a tragedy and then to come back. In your mind, maybe, in I don't know if it's a more psychological sense, but what have you guys sort of done with this flight that will help those that follow in that sense? What are you kind of giving to your colleagues? What is your team giving to your colleagues when they do this the next 2 or 3 times that they didn't have before?
Well, you know, the most obvious would be the technical, and that's that we both developed and then demonstrated all of these new techniques. So on STS-114, it's just a matter of doing them again. Ideally, we will have some lessons learned, and it will be easier for us the second time, and the third time it'll be easier still. That's the obvious technical. You know, psychological, I don't know, I guess it's hard for me to speak for the whole community. I said before that I am inspired once again by the flight control team. I hope that anybody internal to our community that was doubting whether or not the folks at the working level, the guys that really do the number crunching, the folks that really turn the wrenches and cut the metal, if there was anybody that had any doubt that those people could really do this tough business of manned space flight, I hope that, if nothing else, the last 2.5 years of watching us solve impossible problems and then fly again with this orbiter that is in perfect condition, I hope that is enough to remind people that this NASA is just as capable of doing impossible jobs as we were 40 years ago, as long as we lead them well.
Gina?
I just want to ask a follow-up weather question as I'm sitting here thinking, oh goodness, do we have to go to California? How far out in front will your team be able to make that decision, or Leroy's team be able to make that decision about whether and a landing in Edwards?
Oh boy. Well, I hate to tell you, I don't want to steal Leroy's thunder, and I don't want to commit him to having to land somewhere when he might have wanted to go somewhere else. I would expect that Leroy would make that decision on the day of entry, unless the weather was just so bad before he had the crew suited up and got ready to try landing on the first attempt. I would be surprised if in any case he gave up on a Florida landing until Monday morning. But I guess it is possible that the weather would be so socked in and no chance of having good weather in Florida that he would have to change his plans. But we're nowhere close to that now.
And in the back, this gentleman.
Eric Berger with the Houston Chronicle. Paul, I know that Leroy might be able to answer this question better. You could defer it, but I'm kind of on deadline, so maybe you can humor me a little bit. Upon reentry, what sensors or indicators might the folks in Mission Control be watching from the standpoint of you have this pieces of the thermal blanket may break off, or you had tile problems last time? Maybe you could just talk a little bit about some of the important indications that the people will be watching.
We'll have a team of folks primarily in the engineering room that will be watching a lot of detailed data on thermocouples, glorified thermometers that are inside the structure in various places, both inside the wing and parts of the fuselage. And we have those teams watching on all missions. We had folks watching data like that during STS-107. There are folks on the flight control team that are watching those temperatures as well. I can't say that we have any greater focus on those temps today based on any damage we have on the bottom of the vehicle or even the window blanket. Because of our level of confidence in the analysis that we've already done. But we do have temperature sensors inside the structure of the vehicle that we're able to watch. We have a lot more that are recorded on board that we see post-flight, but we do have some that we can see on the ground.
Let's see, one follow-up here from Pam.
Pam Easton, Associated Press. Is it bittersweet in a way that Discovery is about to land, knowing that you feel this mission was a success, but not knowing when you may get back up again?
We're all definitely interested in seeing how the investigation down in MAF is going with the external tank, and we are looking forward to seeing the details and seeing if we can put together good technical rationale to understand what caused that problem, and that would allow us to gain confidence in flying STS-121 as early as September. So I wouldn't say that concern is hurting the mood as we're flying STS-114. There's still very high spirits in how successful this mission has gone, the great condition of this orbiter, and the good job this crew has done for us in orbit.
Okay, I would remind folks that on Sunday morning at 6:30 a.m. Central Time, Leroy Kane will be here for a mission status briefing to preview landing the following.
And Canadarm2 slowly backing away from the grapple fixture on the Raffaello multipurpose logistics module.
We copy, Vegas, thanks. We concur.
Houston Discovery on air to ground 2. Are you ready for 3.10502 repress inlet?
Discovery Houston on air to ground 2. Eileen, yes, we are ready for 3.10502 repress. And note, we've already completed step 1, and we confirm in step 2 that we're in a good cryo config. So you can proceed starting with step 5.
Okay, I'll inhibit those 2 hardware limits, and then I'll proceed with, actually, step 5 is already complete. I cleaned the filter just a few hours ago. Do you still need the OCAC power to off?
Discovery Eileen, yes, we'd like the OCAC power to off.
Okay, I'll call when complete.
This is Mission Control Houston. International Space Station cameras capturing the movements of Canadarm2 as it moves up into the handover position for the orbital boom sensor system after completing berthing of the Raffaello multipurpose logistics module into Discovery's payload bay. Jim Kelly and Winnie Lawrence in the Destiny Laboratory module once again maneuvering Canadarm2, the larger of the 2 robotic arms on orbit, into position to grapple the orbiter boom sensor system. This 68-foot-long robotic arm will grapple the 50-foot-long orbiter boom and sensor system. As its little sister Canadarm, 50 feet long on its own, holds the orbiter boom sensor system perpendicular to Discovery's payload bay for this transfer. We now do have a downlink from the International Space Station, however, looking as the 2 robotic arms maneuver the orbiter boom sensor system into position for the handover so that the space station's robotic arm can rebirth it into Discovery's payload bay after it's got its first major workout on this mission.
Discovery Houston, we are grappling.
Robotics officer reports a good capture.
Go ahead on O2 repress, Houston.
Eileen, we are complete with the O2 repress. We see good pressures. You are go to perform steps 7 and 8. Correction, 7 and 9 to clean it up, and that will complete the procedure for you.
Understand steps 7 and 9. We'll put it in work.
Houston Discovery, head to ground 2 for photo TV.
Go ahead, Soichi.
Hey, Julie, for the photo card, you just have one more full PC card. I know you guys are downloading from the ProShare, but like we discussed yesterday, if you can use station side SSC, if you give me an instruction, I can do the I can go to the station at this time and insert the card on their side.
Andy Thomas and Charlie Camarda guiding Canadarm through its paces this morning from the flight deck of Discovery.
On the big loop, Vegas, you have a go to maneuver the OBSS to the off position.
We copy that, Andy, and we show that Shuttle can go back to attitude control. Our procedures say LVLH, damp the rates, free for 2 seconds in auto, unless ground gives you a go to go directly to auto.
Now receiving sequential still video images of the baton twirl, as Jim Kelly called it, with Kelly having accepted control of the orbiter boom sensor system from Andy Thomas and the shuttle's robotic arm, turning it essentially 90 degrees so that it will align with the starboard sill of Discovery's payload bay.
Discovery Station, all our joints are limped and our carriage is de-rigidized. You have a go for complete latching. Discovery copies in work.
Houston Discovery, airplane.
Houston Alpha, we have good latch indications of the boom in the payload bay.
Houston copies, Andy.
And Houston from station on the big loop. We want to thank everybody who's worked so hard on the OBSS. It's performed flawlessly this mission. And a special thanks to all the folks who worked really hard on this birthing procedure. We have something special for them.
Wendy, we copy and congratulations on doing such a great job again. It's just amazing. Each day you guys seem to be getting better. We appreciate the kind words.
Commander Collins, I had a wonderful visit with your husband this morning, and he's complaining mightily that he had to go and get the school supplies for the first time, and he wasn't sure if he did it right. So where are you?
Well, I
think maybe I might have some cleaning up to do when I get home. But no, I think he can do a great job, and I think he's, with me being gone, he's learning how hard it is to be a parent, but he's a great dad, and I hope he's enjoying the time with the kids.
You know what? He was the happiest person I saw this morning. He was upbeat. He is having a great time and so supportive of your being up there and so excited for you to come home.
Well, thanks. It's good to hear that, and I'm looking forward to seeing my family again, too, and I'm looking forward to getting back to Kennedy Space Center and Johnson Space Center and saying thanks to not just my family, but to all the folks that worked so hard to make this mission successful. It's really been just a fantastic experience.
Well, I hope you know that everybody on Earth is so excited watching everything you do, watching the repair job that was done, and so pleased that that went so smoothly. So we're all very, very excited and proud that we've had a great return to flight. And we love all of your crew, and we can't wait to welcome you back.
Well, I do want to say that all the crew is listening right now, and they've all done just a great job. Wendy Lawrence has been flying the station robotic arm, and she flew Steve Robinson in to pull the gas filler out of the nose, and they both made it look easy. And we also have Suichi Noguchi, who did his EVA. It's his first flight, Charlie Camarda's first flight. We have Jim Kelly, who's the pilot. Andy Thomas did a lot of work getting our spacewalk crew members ready to go, and I'm just really proud of this whole crew and how well they've worked together and just really been dedicated to the mission.
Commander, that is so great that all of you are there, and I understand you're going to be going to sleep in a couple of hours. And Congressman DeLay, who has been so supportive on the other side of the rotunda of your efforts and the space program, is going to say a few words to you now, and I'm going to sign off.
I want to thank you. It's really great. It's very motivational to be able to talk to you. So thanks for taking the time out to come to Johnson Space Center and meet the people that are working in the space program. We really appreciate it.
Commander, this is Congressman Tom DeLay. I just wanted to thank you for a great and successful mission. I have been so excited watching everything that you guys have been doing. We're very, very proud of you and the NASA family, and we are looking forward to a safe return. And most importantly, I want to thank you for participating in something bigger than all of us, and that is the beginning of a space exploration and the fulfillment of the President's vision. It is very exciting, and what you are doing to motivate young people to get in to the space program is just amazing. We've already seen results of it. I have spoke to the USA family and yesterday, and they are so excited about the success of this mission. I just congratulate you all. It's just so exciting to be to watch you and to know that the space program is up and flying now, and we're looking forward to the future.
Well, thank you, Congressman DeLay. Those are great words for us to hear. Right now we're flying over, we just flew over the northern part of the United States and Canada, and we're looking down at absolutely beautiful Earth. We're seeing clouds and lakes and rivers. We've seen the southern lights, the auroras, many times today. The Earth is just so beautiful, and this is so motivational for us, and when we come back, we're going to share our experiences with all the workers in the space program and with young people that we hope to also motivate to get into math and science someday and continue with space exploration.
Well, thank you so much, and I just we're all praying for a safe return, and we hope that everything goes well from now until next Monday. and we know they will because you guys are so well trained and so committed to making sure that this mission is successful. And it shows the entire United States that Americans can accomplish great things along with their international partners.
And I agree with that. And space exploration isn't easy. It's hard, and we're learning new things. We're taking risks as we go along. Not everything is going to be 100% successful, but the important thing is that we're learning, and we're always making it better. So appreciate those words.
Well, God bless you, and I'll sign off now. You get some much deserved rest, and we're looking forward to seeing you when you come home Monday.
Okay, we're looking forward to it too, and thanks for taking the time out to talk with us. It's really great, and we appreciate it. Have a good day.
I think this is the last big step for the EVA-related procedure. I like to thank all of the people, the NASA and NASA JC and the flight controller team. And at the end of EVA, we give a big thank you for our EVA team, Cindy and our other folks. But I'd like to extend our thanks to the other folks we all do for the last 4 years. Lisa Spence, Bridget Johnson, Glenda Laws, Mike Embry, Dana Weigel, and John Ray. Also from our colleagues from astronaut office, Dave Wolf, Joe Tanner, Jerry Ross, Scott Marzin, Jim Riley, Danny Olivas, Pierre Sellers, Gretton Brown. And also, we spent a lot of time at the VLF, Dave Hansen and other folks at VLF. Thank you very much.
Houston, this is Andy, the former IV. I'd like to reiterate those thanks especially to Cindy Begley and Matt Mars and Alison Bollinger, who put in all of those long hours in the time before the flight and then probably even longer hours during the flight to help us make those EVAs successful. Thank you very much for those Herculean efforts.
And that EV2 chime in here and just say, me too. You know, we're probably the best rested members of the whole EVA team, and it's now time for you folks to head down to Pinches and then get some sleep.
And Steve, Soichi, Andy, we copy all. Thank you for those words. I know that the EVA team, Cindy is listening, and many others right now, but we'll pass the word to those that are in bed already. And for having seen them work here in the flight control room, they've done extraordinary work, but this is indeed teamwork, and thanks to you guys for performing 3 beautiful EVA. This has been a good mission.
Hello, Eileen. Our team just wanted to give you a little farewell from us working with you on this flight. The Orbit 2 team under the direction of Flight Director Mark Ferring, all the folks here in the ISS control room has had a pleasure working with you for the past week and a half, and it's really been a highlight for each one of us. We really enjoyed watching all your great work and being a part of the big team. It's been very satisfying and a lot of fun. And we wish you well for the remainder of the day and a good return. For Sergey and John, it's really been a privilege working with you during these docked operations, and we wish you well for continued success on the rest of your increment. And Eileen, for you, Vegas, Soichi, Steve, Andy, Wendy, and Charlie, it really has been a wonderful experience getting to be here on the execute shift. We were here for most of your robotic ops and for your EVA activity, and for a lot of other stuff you were doing. We had the privilege of being in the execute shift to actually be here on console while you were doing it. We look forward to seeing you next week when you get back. Thanks very much. This is going to be our last shift. In a couple hours, we'll still be around for a couple hours, but we're going to be leaving here in about 2 hours or so, and the Orbit 3 team will come on, and they'll be led by Joel Montalbano, and then after that, the Orbit 1 team with Brian Lenny will be here, and that'll be it, and then we'll go back to stage ops on the station side. So we wish you well, and look forward to seeing you back here.
Hey,
thanks, Mike. That's a very, very nice message, and I think it's a wonderful way to end a great mission. And to Mark Ferry and all of your team, we've been working with you now, for the better part of 4 years for us, and it's just been a wild ride. And we've been happy to finally put the icing on the cake, do this mission, work with you. It's been so successful. We are so happy that things have worked out as well as they have. So our thanks to you, and we'll be seeing you next week once we get back. And we hope you had a good one also. We'll talk to you on the ground. Bye-bye.
Great, Eileen. Thanks. And everyone here is looking forward to the plaque hanging. We'll see you next week. WLAS activation is complete, and message 139 is also complete. And I'm really impressed. That WLAS system is one robust system. It's still working, and haven't had one hiccup the whole flight from the crew's point of view. And we just can't wait to see some more of the data when we get home. So congratulations to the folks who put this whole system together. And I think it's really great to have so much data on our bird.
And Steve, we copied those words, and I can tell you that you've just made a bunch of people happy with those words. We appreciate you saying that. Thank you very much.
Good morning, Discovery. And the wake-up music this morning should have reminded you just a little bit about the Air Force and especially Vegas. And we hope that the music gave you just some clue as to what we're planning for today's activities. So with that, happy Undock Day.
And thanks for that, Shannon. And I want to mention again our new Colonel Jim Kelly on board. Congratulations to him on his promotion.
Absolutely.
Discovery Houston, just to close out the O2 repress procedure, once you've turned on the OCAC power in step 9, we can show that you can exit the procedure. Step 10, you are good on the cryo config. Step 11 is not required, and ECOM will take care of step 12.
Okay, I show us complete with the procedure. The OCAC, the direct O2 is closed and the OCAC is on. And for the caution and warning, we still have the cabin atmosphere light. We tried to clear it on panel C3 with our no joy.
Okay, copy, Eileen. We're still thinking about it.
And that minor troubleshooting procedure reported by Commander Eileen Collins is for a caution and warning display that's reporting an oxygen flow message, but there is nothing wrong with the cabin atmosphere. This apparently is related to instrumentation, and the crew on board is attempting to reset the caution and warning display to get rid of that message.
Houston, the next step on the cabin atmosphere light is we'd like you to go ahead and inhibit parameter 14, inhibit 1-4. We expect that to extinguish the cabin atmosphere light on F7.
And what?
John Phillips on the right, the Expedition 11 flight engineer. Charlie Camarda in the field of view. You saw Steve Robinson just a moment or two ago.
And for Houston and all the folks that are watching us now, we thank you for sharing the farewell ceremony with us. It's really not a final farewell because I'm sure we'll see John and Sergey again after the flight. And what we're telling them here is we thank them for being such great hosts. We thank them for being part of such a successful mission. We're so happy to have spent the time up here with them. We've not only got some great work, fellowship and camaraderie, and these are memories that we'll have forever. So we thank them, and with that we are going to say just a short goodbye, and we're going to do a fly around of their space station and get them some great pictures and do a photo survey and add some final memories. So with that, we'll pass it to Sergey.
And we want to say thank you, all of you, and thank you to the ground who support this mission. It's a really big event for us because we were waiting for this flight for several years, more than 2 years already. And fortunately, everything goes smooth. We want to say thank you to you and wish good soft landing.
Thank you so much for being wonderful guests. It's really been a pleasure. And no, we're not glad to see you go. We'd love to have you stay. We'd love to have you stay a little longer. And as Sergey said, have a great flight, soft landing. We look forward to seeing you in a few months back in Houston.
Final hugs and handshakes for the 9 crew members on the shuttle station complex as Discovery's astronauts now make their way back through pressurized mating adapter number 2 into the shuttle, leaving behind John Phillips and Sergei Krikalev.
Discovery departing.
Flight engineer John Phillips with the traditional ringing of the bell, marking the departure of the crew that arrived 8 days ago to begin joint docked operations, highlighted by the delivery of several tons of supplies and equipment and 3 spacewalks, leaving behind a healthy control moment gyroscope, a new tool platform, and other hardware for the future assembly of the International Space Station. Now back on their side of the docking interface, Discovery's astronauts will begin the procedure to close the hatch between the orbiter docking system and pressurized mating adapter number 2.
Of the duct removal and hatch closing bypass config procedure complete. Thanks, Scorch. We're going to be putting step 3 in work very shortly.
Okay, at your convenience.
Station communicator Charlie Hobaugh reporting to John Phillips on board the station that the removal of air ducts that has enabled the flow of air between the two vehicles over the past 8 days, that will be put in work as the precursor to the actual closing of the hatches.
With the ODS upper hatch closed, we are go.
And we can verify that the ODS upper hatch is closed, and Andy and I will start putting the depress in work.
Okay, good news. Thanks, Wendy.
And with that call from Wendy Lawrence, confirmation that hatches are now closed. The final hatch closed at 12:14 a.m. Central Time, and the green light given for the start of the procedures to depressurize the vestibule connecting the shuttle's docking mechanism and the station's docking mechanism.
Copy, we'll select auto on the DAP.
Jim Kelly at the controls of Discovery configuring systems prior to undocking, now just 1 hour, 10 minutes from now.
That complete.
And above the shuttle airlock, you can see the orbiter docking system.
Discovery has attitude control. Station copies.
Orientation control of the shuttle station stack is now in the hands of Discovery and will remain so through undocking. Again, above the shuttle airlock, you can see the orbiter docking system mated to the black cylindrical object, which is pressurized mating adapter number 2, the forward docking port on the Destiny laboratory, and of course Destiny in the upper left-hand corner of your screen. Here in the Space Shuttle Flight Control Room, Lead Flight Director Paul Hill now polling his team of flight controllers for a go for undocking.
Complete. Houston Discovery on air to ground 2, docking mechanism power up and undocking prep complete.
Copy, Wendy. Thanks for the tag up.
The motion that you see in the aft flight deck windows of Discovery, just behind the docking mechanism, is that of pilot Jim Kelly, who will be executing the undocking and the fly-around of the orbiter of the International Space Station. Just 3.5 minutes away from undocking, everything in readiness. All quiet in the shuttle flight control room, 30 seconds away from undocking.
Houston End Station, we have physical separation.
Houston copies.
Undocking confirmed.
Station copies.
Discovery taking the first step on the road home to the Kennedy Space Center. The Guidance, Navigation, and Control Officer reports good trajectory control systems measuring the distance and the rate of separation between Discovery and the station. This view from the centerline camera mounted in the orbiter docking system, the docking mechanism that is located just behind the aft bulkhead of the crew cabin. This shows head-on the cross target for pressurized mating adapter number 2 on the forward hatch of the docking port at the forward end of the Destiny laboratory of the complex.
Discovery at Houston Station is in attitude control.
We copy. Station's in attitude control.
Houston copy.
With the on-time undocking of Discovery at 2:24 a.m. Central Time, the 2 spacecraft undocked 223 miles above the Earth over the Pacific Ocean west of Chile after 8 days, 19 hours, and 54 minutes of dock time together. A good view of the forward docking port on the Destiny laboratory of the International Space Station as Discovery begins to move out to a distance 400 feet in front of the A good view of the forward docking port on the Destiny laboratory of the International Space Station as Discovery begins to move out to a distance 400 feet in front of the station. The rendezvous officer here in Mission Control reports a good rate of opening between Discovery and the International Space Station. Pilot Jim Kelly flying away from the station to a distance 400 feet directly in front of the station along what is called the velocity vector, or V-bar, the direction of travel of the 2 spacecraft. Once he reaches that point 400 feet ahead of the station, he will initiate a fly-around, a radial fly-around nose first, to a point 400 feet directly above the station, behind the station, and below the station, before continuing the fly-around to 400 feet in front of the station, at which point a separation burn will be conducted to depart the vicinity of the complex for good.
We think we may have seen some debris from camera Bravo. We're not totally sure. We didn't get any photographs of it because it's a little bit dark out, but we wanted to check with you and see what you saw.
We thought that was a reflection in the camera. If that looked like something different to you, we'd like to hear about it.
We actually weren't sure. We discussed a reflection and possible debris, so we weren't really sure if it was one or the other.
And just to clarify, Discovery.
You saw in camera Bravo.
Yeah, just to clarify, Discovery, did you see it just on the monitor, or did you also see something out the window?
We did not see anything out the window. It's too dark for us to see anything.
Okay, copy. Thanks a lot.
Yeah, all we saw is what you saw, and we'd just like to get an idea of what y'all think there on the ground.
We don't have any concerns because of the motion we saw in it. We think it was just glare.
Okay, copy. We'll go for the fly round.
the instrumentation and communications officer here in Mission Control, slewing the elbow camera on the shuttle robotic arm around to capture a view of the International Space Station coming into view. And again, from left to right for reference, the Destiny Laboratory of the International Space Station, which was the docking port for Discovery, the huge U.S. solar arrays in the middle of the complex, the Russian segment of the International Space Station, and on the far right of your screen, the Progress resupply ship, the Progress 18, docked to the aft docking port of the Zvezda service module. The International Space Station, as seen from the Shuttle Discovery, 400 feet separating the two spacecraft as they fly over southeastern Russia. Discovery has completed the point of its fly around where it was directly above the station, now moving to a point behind the International Space Station, which has maneuvered back into its normal operating orientation relative to the Earth. the International Space Station flying over Kazakhstan, the launch site for Soyuz vehicles, launching Russian cosmonauts and American astronauts to the station. The International Space Station now flying over the Himalayas and Mount Everest, about to reach a point at which it will be seen over the limb of the Earth, beginning a northwest to southeasterly swing at an altitude of 224 statute miles.
Station Houston, no response required. Just an update. Discovery now approaching the negative V-bar directly behind you. Should be directly underneath in about 11 minutes and change.
At a distance of 456 feet directly behind the International Space Station, pilot Jim Kelly continues his fly around. We're about 27 minutes away from the first separation maneuver, the first of two that will enable Discovery to depart the neighborhood of the International Space Station for good. The station currently flying over southwest China, about to swing just across the northeast coast of India. Aboard that complex, the International Space Station, Sergei Krikalev and John Phillips in their 113th day in space, their 111th day aboard the station since arriving on April 17th in their Soyuz TMA-6 capsule. And again, this view of the International Space Station through sequential still video. This is the video system that refreshes the frames about every 30 seconds. The fly around continues, everything in good shape, all systems functioning normally. Just over 2 hours after the shuttle undocked from the station, it maintains an opening rate and a good view from the cameras on the International Space Station as the shuttle continues to depart from the orbiting complex. Soichi Noguchi now providing a videotape replay of the video he shot of the International Space Station during Jim Kelly's fly around to the complex. At the bottom of your screen, the Progress 18 resupply ship mated to the aft docking port of the Zvezda service module, the Zarya module. In the middle of your screen, the first element of the International Space Station launched on November 20th, 1998.
I just wanted to let the folks down there know that on our, it's kind of interesting, on the very southern part of our orbit, down south of Australia, we have seen some of the most fantastic auroras, southern lights, that I've never seen before, and I don't think anybody else up here has seen them this bright. We just thought we'd let you know.
Well, Eileen, that's very interesting because our INCO's been up and down the room during that pass because the cameras had caught it as well, so we got a glimpse on the ground. They were indeed fantastic.
Yeah, it's really worth looking at. I think they've been getting a little bit brighter as the flight's going on, or maybe we just have more time to look at it now. But it's definitely worth a look at on your next pass if you can.
Eileen, thank you. We appreciate it. We sure will. And since we're talking about some treat, this morning at 5:46 local, everybody that could be freed from the flight control room walked outside and we looked at the sky because we were expecting you. Just before that, we saw a satellite pass by that just happened to be the Hubble Space Telescope, and then a few minutes later, we could distinctively see two little stars, one not as bright as the other, right in front of it. That was the space shuttle in front of the International Space Station. And Fido and his backroom were quite proud of their trajectory, but it's GNC that pinpointed that you guys were flying upside down and in reverse.
Wow, that's fantastic that you were able to see that. I got to tell you, the view up here was just tremendous. I can't find the words for it, but it really was something, and we've documented it pretty well. So, you know, we wish you were up here with us, but we'll share the photos and the videos when we get back.
Well, thank you. We're playing back some of the highlights of the mission here at Mission Control on this off-duty time, and you guys have absolutely incredible video from ASCEND to up to now. We're watching EVA3 now, and it's excellent.
You know, we're looking forward to seeing some of the ASCEND videos because we've been getting emails from our family saying it was really spectacular. So we're going to get to see this mission from a whole new perspective when we come down.
No kidding, it was spectacular, and there's more video from this ASCEND than I think all ASCEND combined since we've been flying. So yes, you'll be able to see it from every single angle you wish. But you might be glad to know that preliminary reports show that weather looks good for landing at KSC on Monday. However, this is, of course, August in Florida, so we'll see.
Yeah, that's why we like it here in space, but thanks for the information.
So again, we'd like to sign off Orbit 2 here, and just to let you know that, again, seeing the two flagship of the human space exploration passing overhead in Houston this morning was a great treat for the flight control room, and there is a second opportunity to wave at you as you pass by tomorrow at 6:13 local in Houston, and as much as possible we'll be there to see you pass by. Good night.
And great, and we appreciate that, Julie, and we look forward to passing by.
Copy that. Good night, everybody.
And good night.
Ausgeparkt ganz ohne Schulterblick und Rückspiegel. Teil 1 des Projekts Die Rückkehr der alten Dame Discovery zur Erde ist geschafft. Mission accomplished sozusagen. Nach 9 Tagen löst sich das Space Shuttle von der Internationalen Raumstation. 9 Tage hat die ISS-Crew, bestehend aus dem Russen Krikalow und dem Amerikaner Phillips, der Discovery-Besatzung All-Asyl gewährt. Nun der Abschied, der vorübergehende Abschied, beeilt man sich zu sagen. Es ist kein Abschied für immer, denn wir sehen John und Sergei ja wieder nach unserer Mission. Wir wollen nur Dankeschön sagen dafür, dass Sie so großartige Gastgeber und Teil dieser erfolgreichen Mission waren. Wir sind glücklich, dass wir hier oben bei Ihnen sein durften. Aufregende und riskante Tage liegen hinter den Astronauten. Der Höhepunkt, die Handarbeit am Rumpf der betagten Fähre, wo 2 Plastikstreifen an der Hitzeisolierung entfernt werden mussten. Erfolgreich, da ist sich die NASA sicher. Kosmonaut Krikalow gibt dem Shuttle deshalb mit auf den Weg, was ihm alle wünschen. Euch allen sagen wir Danke und euch am Boden, die ihr unsere Mission unterstützt habt, auch. Es ist ein großes Ereignis für uns, denn auf diese Mission haben wir jahrelang gewartet. Und nun, nach 3 Jahren, läuft alles so glatt. Dankeschön, wir wünschen euch eine gute, weiche Landung. Am Montag soll die Discovery dann in die Erdatmosphäre eindringen, der kritische Moment, und dann wohlbehalten in Cape Canaveral in Florida landen. Der Pannenflug der alten Dame wäre dann doch noch ein erfolgreicher geworden.
Wir sind natürlich auch dabei. N24 überträgt die Rückkehr der Discovery am Montag live ab 10 Uhr.
Discovery hat den Rückflug zur Erde angetreten. Um 9:24 Uhr unserer Zeit löste sich der Shuttle von der internationalen Raumstation. Die Besatzung der ISS machte dabei Fotos von der Außenhaut der Discovery, um mögliche weitere Schäden zu entdecken. Zuvor hatten sich die Astronauten im Weltall voneinander verabschiedet. Die Discovery soll am Montagvormittag in Cape Canaveral landen.
Nun schwenkt die Discovery auf eine eigene Erdumlaufbahn ein. Am Montagmorgen unserer Zeit soll die Raumfähre mit den 7 Astronauten an Bord zur Erde zurückkehren.
And the crew of Space Shuttle Discovery is getting ready for the return back to Earth. The shuttle departed the International Space Station Saturday, but not before hugs and handshakes with the 2-man Russian-American crew that remains aboard the space station. Discovery was the first shuttle to visit the station since 2002. The space shuttle is scheduled to complete its mission on Monday. That's after 13 days in space, with a scheduled landing in Florida. It will be the first shuttle return since the Columbia disaster. NASA officials and the shuttle crew have expressed confidence that Discovery is safe for that re-entry. I'm Rosemary Church at the CNN Centre. I'll be back with an update of the headlines after the short break. We leave you now with some sounds and images from Hiroshima as Japan marks the 60th anniversary of the world's first atomic bomb attack.
For the crew, time to say goodbye to the Russian cosmonauts aboard the space station.
Now, we thank you for sharing the farewell ceremony with us. It's really not a final farewell because I'm sure we'll see John and Sergei again after the flight. And what we're telling them here is we thank them for being such great hosts. We thank them for being part of such a successful mission. We're so happy to have spent the time up here with them.
We want to say thank you, all of you, and thank you to the ground who support this mission. It's a really big event for us because we were waiting for this flight for several years, more than 2 years already. And fortunately, everything goes smooth. We want to say thank you to you and wish good soft landing.
Houston End Station, we have physical separation.
And then a smooth manoeuvre as Discovery first backed away from the space station, then slowly looped around it. The shuttle's cameras broadcast these pictures of the outpost in space and a spectacular view of Earth. But Discovery may be the last shuttle to visit the station for some time. That's because of the recurrence of the problem that caused the Columbia disaster 2 years ago. Foam falling from fuel tanks during the launch. David Chazan, BBC News.
Trotz der Risiken hat das Space Shuttle Discovery heute von der Raumstation ISS abgekoppelt und ist auf dem Rückweg zur Erde. Die NASA hatte grünes Licht für den Rückflug gegeben, obwohl eine Isolierdecke an einem Fenster leicht beschädigt ist. Nach dem Abkoppeln der Discovery machte die 7-köpfige Besatzung Fotos von der ISS, um sie auf Schäden zu überprüfen. Am Montagmorgen soll die US-Raumfähre in Cape Canaveral landen.
NASA viewed the repairs essential to ensure the shuttle is safe for re-entry into the Earth's atmosphere.
Today marked a new chapter in the history of shuttle missions.
See you later, Steve. Talk to you later.
A cheery goodbye from Mission Control for astronaut Steve Robinson, now emerging from Discovery.
I'm in the great outdoors.
This is the view from the helmet camera on Soichi.
Floating around him, the tool bags and other equipment needed for a precarious task. This, a defining moment in America's return to space.
As he is now on top of the Destiny laboratory making his
220 miles above the Earth, Discovery's nose cone looks serene, in great shape, but underneath there's potential danger. 2 ceramic strips filling the gaps between vital heat shield tiles have come loose and could cause Discovery to overheat on its way back to Earth.
We are go for EVA on
After days of deliberations, NASA decided a difficult spacewalk was needed. On the end of the International Space Station's robotic arm, an astronaut would have to float beneath the shuttle's undercarriage and fix the problem, a maneuver that's never been tried before. The moment of truth. Steve Robinson about to take the most important walk of his life. His helmet camera capturing everything, and approaching Discovery's belly, he mustn't damage the heat shield tiles.
Your feet are well clear, your head is well clear, your hand is perfect.
Then the delicate work begins.
Okay, I'm grasping it and I'm pulling. It's coming out very easily. Beautiful. Nicely done, Steve.
I was absolutely relieved, and I think you could probably hear the sigh of relief throughout the building over there. And when he pulled the second one out, it was a huge relief, and it definitely felt like the rest is downhill from here.
There are new concerns about a thermal blanket below the cockpit damaged on takeoff last week. But for NASA, in the words of astronaut Steve Robinson, this was a pretty good day in space.
How's that, Steve?
Clive Myrie, BBC News, Washington.